Good afternoon. Singh Sawan, Kim Heng, Say Nuj, Kim Heng, and others. Guys, good to see you again. I hope we are all doing well. So we have another short session today. Okay. So yesterday we talked about indefinite integrals and the substitution methods and substitution and area between curves. And today I'm going to show a bit more examples related to these concepts. Okay, as much as we can. And tomorrow also we will maybe practice some questions related to these concepts. And on Thursday we will start chapter 6. And these examples that I'm going to show today, actually I just selected some questions from exercise 5.5 and 5.6. Okay, they are a little bit, let's say, not challenging, but long. We have to use the same method multiple times, maybe 2 or 3 times. Okay, that is the challenging part of these questions. Okay, so I have selected 4 questions from exercise 5.5, and so if you have any questions, you can ask during this lesson. If you have more time, I will continue. Otherwise, tomorrow we will solve questions from exercise 5.6. Okay. And also you may wonder, why did I choose questions from exercise 5.5 and 5.6, not 5.1, 2, 3, 4? Okay, those are basic concepts, okay? And those concepts actually must be used to solve these questions. And that's why I just skipped those exercises, exercise 5.1, 2, 3, 4. But still, if you have any questions from those exercises, let me know. You can just send it through Telegram, okay? So I'll just prepare the slide and also try to show those questions in our tomorrow's class. Now we have to evaluate this integral. It looks a bit scary, but what we have to do is, if you look at the expressions, 2r minus 1, 2r minus 1, they are used repeatedly, right? And that's why we are going to use the substitution methods a few times, maybe 2 or 3 times. What am I going to start here is, maybe in one step you can do that, but I just want to do this step by step. Number 1, first let me introduce this variable. Okay, let's say u is equal to 2r minus 1. Okay, so at the time immediately from here, what is du? Du will be equal to 2 times dr. That means that instead of this dr, right, we can write 2 dr. I mean du is equal to dr, or instead of dr, I can write 1 over dr. So let's say this integral is I. So I is equal to, so this 1 over 2, right? Instead of dr, I'm going to write 1 over 2. Let me just give 1 over 2 outside this integral. Here we have integral 2r minus 1, that is u. And here we have cosine square root of 3 times u squared plus 6. And over here we have square root of 3 times u squared plus 6. And here we have the u. Okay, that's the first step. Now in our second step, let me just take this into the box as our first substitution. And the second one is, as see here we have u and du, right? And u and du, let me just show it here. Okay, so this du, I can just write it as, for example, let's say if I just put this inside 6, 1 over 6, right? And here we have d, what is it? Sorry. I think first I have to introduce this one. Suppose that actually t is equal to 3u squared plus 6. That's my second substitution. If you differentiate both sides with respect to t, or what is the differential of t? Differential of t is equal to 6 times u du, right? Yeah, just differentiating both sides with respect to u. Now, if I just take the 6 to the left-hand side, at that time here we have 1 over 6 dt will be equal to u du. This is my new substitution. So instead of this u du, I can write 1 over 6 dt. So that next step will be equal to 1 over 6. Here we have 1 over 6, 1 over 2 times 1 over 6. And here we have integral. And here we have cosine. What is square root of this 3u squared plus 6? That's equal to t, right? Here we have square root of t and over. And here we have square root of t. And here we have d, what is it? Here we have dt. Okay, here we have dt. Let's close this. That's our second substitution. Now I can just continue from here, equals. And what is 1 over square root of t? I can actually use one more, but I don't want to use this. That much is enough, I think. Here we have 1 over 12 times integral. Here we have cosine of square root of t. And I can write here square root of t. Why is it so? Because what is the differential of d square root of t? Let me just write in, I'll delete this. Differential of square root of t, that's equal to 1 over 2 times 1 over square root of t and dt, right? So instead of this dt over square root of t, we can write here 2 times d square root of t. So that's why here we have, what is it? Here we have 2. Okay, here we have 2 and cosine of square root of t dt. All right. Now we can just consider this square root of 2 as w. Okay, you can just w, and this will be equal to 1 over 6 times and cosine of x and dx, right? Because they are the same thing. Here we have cosine of x dx. So what function's derivative is cosine of x? That's equal to sine. So here we have sine of square root of t and plus c. Or now I'll just change this. That's equal to, and what is t? T is equal to 3u squared plus 6, right? So dot, 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 the answer will be 1 over 6 times sine of square root of t. What is t? 3u squared plus 6. So 3 times u squared. What is u? U is 2r minus 1. 2r minus 1 squared plus 6 and the plus c. So if you differentiate this 1 over 6 times sine of square root of 3 times 3, 2r minus 1 squared plus 6 plus c, you will get this function, which is actually the integral of this integral. Another similar example, evaluate the integral. Integral sine of square root of theta and over square root of theta times cosine of cube and what is it? Cosine of square root of theta cube and d theta. So if I just rewrite this, I feel more clear. Let's say this one is equal to integral. So this integral is equal to square root of and sine of square root of theta, right? And here we can write it as square root of theta times square root of cosine cube square root of theta. Okay, and here we have d theta. And we had just changed this. What is d theta over square root of theta? We just did this in our previous example. This d theta over square root of theta is just equal to 2 times square root of theta d theta, right? Because if you differentiate 1 over or theta to the power of is it minus? It should be minus, right? Because we have minus here. So minus 1 over 2. So it's minus 2, this minus. In the previous also, sine of theta. Okay. It should be minus here. It should be minus. Okay. Minus. Sorry. So it should be minus. So from here, that will be equal to integral. And here we have sine of square root of theta over square root of cosine cube square root of theta. And here we have d square root of theta. And here negative 2 is here. So now immediately, if I just introduce this thing, let's say here we have x is equal to square root of theta. What happens here? Here actually the integral takes this form, simpler form. Here we have sine of t dt over, here we have cosine of t, it is to the power of actually 3, square root of to the power of 3. So I'm just going to write this as to the power of 3 over 2. Okay, so now I can just bring this sign inside, right? So that's equal to, here we have 2 integral, and this cosine is cosine of t to the power of minus 3 over 2. And here we have d, and sine of t dt is d cosine of t. And when you differentiate cosine, it is minus sine of t. That's why we don't have minus now in front of this negative 2 now. So again, if you just introduce, what is it here? Suppose that u is equal to cosine of t, right? We're just using this substitution repeatedly. So at the time, we will have this thing, 2 times integral. Here we have u, not u. Did I use u already? Not yet. Okay, good. So u to the power of minus 3 over 2. And here we have du, which is equal to 2 times u to the power of minus 3 over 2 plus 1 over minus 3 over 2 plus 1 plus c. And minus 3 over 2 plus 1 is equal to minus 1 over 2. So here we have minus 4. And u to the power of minus 3 over 2 plus c. So it's minus 1 over 2, right? So that is minus 1 over 2. Okay. Just write this a bit more clearly. Minus 1 over 2. Okay. So now what is our u? It is cosine of t. T is equal to square root of theta. And at the time, the final answer would be here. Okay. Dot. The final answer is, what is it? Minus 4 square root of u. U is cosine of t. T is square root of theta, right? And plus c. So which means that if you differentiate this function, minus 4 times square root of cosine of square root of theta plus c, it gives us the sine of square root of theta over square root of theta cosine cube and blah blah. All right, another example, question 59. Solve the initial value problem. Here, let's suppose that maybe s is a position function or in general any function. So if you differentiate twice this s with respect to t, it's given that, right? That's given as negative 4 times sine of 2t minus pi over 2. And s prime of 0 equals 100. S of 0 is equal to 0. Okay, this is called initial value problem. Why initial value? Because if t is changing from 0, right, at initial position, its values are given. It's slow by the rate of change, and also its value is given here. So anyway, how do we do that? Number one, first we have to actually find s prime. What is s prime actually? This s prime of t is just equal to, we have to integrate this function b, or let me just write here, it is s double prime of t dt, right? Which means that integral, we have to integrate this function 4 times sine of 2t plus pi over 2, and here we have dt. Because if you remember the first the fundamental theorem of calculus, right? If you differentiate the function and after that integrate this, it gives us the original function back. So now it is differentiated this, so I'm integrating this, we get the s prime here. So now if you integrate this, that's equal to, let me just make some adjustment here, because here our independent variable, right, it is t, but here in the argument we have 2t plus pi over 2. So I can just do it like this, negative 2. Here we have integral. Here we have 2 times sine of 2t plus pi over 2. So here we have sine of 2t plus pi over 2. And how about this differential is, you can just write it as 2t plus pi over 2. Because differential of 2t plus pi over 2, that's equal to 2 times dt. Okay, and negative 4, I just wrote it as negative 2 times 2. So now I will introduce new variable here. Suppose that u is equal to 2t plus pi over 2. So at the time, our integral takes much simpler form here. So that's equal to -2 integral. Here we have sine of u and du, which is equal to what function's derivative sine of u? It is minus cosine of u, right? So it's equal to 2 times cosine of u, okay, cosine of u plus c. Now, what is cosine of u? So that means that here dot 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 s prime of t is equal to 2 times cosine of u. U is equal to 2t plus pi over 2 plus c. In the condition where I'm just going to use the first condition here, so that is s prime of 0 is equal to 100. Using this condition, we can find the value of this c. So s prime of 0, which is equal to 2 times cosine of, it is minus, so it should be minus, this is minus, minus pi over 2 plus c, that's equal to 100. Now we know the cosine of minus pi over 2, that's equal to 0. Now from here, dot, 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 c is equal to 100. Okay, so now our s prime function is 2 times cosine of 2t minus pi over 2 plus c. So s of t, it's s prime, it's s prime of t is equal to 2 times cosine of 2t minus pi over 2 plus 100. Okay, so now we're going to use actually the second condition and get our function s. In our second step, again, we have to find s. To find s, again, we have to integrate this one more time. S of t is equal to integral of s prime of t, which is equal to 2 times cosine of 2t minus pi over 2, and plus 100, and here we have dt, right? So we have to integrate this. Again, let me just separate them because 100 is just a constant number, or even I can just write it as 100, right? Here we have 100 and t plus, and how about this 2 times cosine of 2t minus pi over 2? Again, I can just write it as cosine of 2t minus pi over 2. And here we have d 2t minus pi over 2, which is equal to, here we have 100t plus actually just cosine of u, right? What function derivative is cosine? That's sine. So that is sine of 2t plus pi over 2 and plus c. So that's our s of t. And also our second initial condition here is, or is it s of 0 is equal to 0. So if we use this one, s of 0, that's equal to, here we have 0, and 0 sine of pi over 2 plus c. So that's equal to 0. And sine of pi over 2, that's equal to 1. And what is c? From here, c is equal to -1. So now we can write our this function. Then s of t will be equal to, what is it? That is 100t plus sine of 2t minus or plus, it is minus minus pi over 2 minus 1, so it will be -1. Okay, c is equal to -1 is correct, right? So 2t minus pi over 2 and the -1. So that is the original function s. Okay, The last example for this 5.5, solve the initial value problem. We have, again, actually the similar question, only the function is different. First, we have to try to find this y prime of x. To do this one, we have to integrate this function for secant square root of 2x, square root of 2x times and tangent of 2x dx. So immediately I can just change this one. Instead of this 4, I can write this 2, okay? And this dx, I can change this to 2x. All right. So now from here, we have secant of t, tangent of t, and dt, right? So if you remember what function's derivative is secant tangent, that is secant function, right? Because if you differentiate secant function, we get secant times tangent, or secant of x times the tangent of x. So I can just write it as 2, take this out. Here we have 1 second left here, secant of 2x, and here we have the secant of x, because derivative secant of x is equal to secant of cos tangent, and secant times secant is secant squared, right? So now here what we have here? Here we have integral u du. So which is equal to, here we have 2, 1 over 2. So that's equal to secant squared of 2x plus c. Okay, so that is our function here. So now using the initial condition, I can determine the value of c. What is y prime of 0? That's equal to secant square root of 0 plus c, that's equal to 4. And for the secant of 0, that's equal to 1. So from here, the c is equal to 4. So which means that dot 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 y prime of x is equal to secant square root of 2x, secant square root of 2x plus 4. Okay. So next thing is we have to actually integrate this one more time to get y of x. So now what is y of x? And second step is y of x will be equal to integral. Here we have secant square root of 2x, and here we have dx. Okay. Okay, here we have y of x equals, what is it, integral secant square root of 2x and dx. Again, immediately just to keep this the same, instead of this x, I can write 2x, and in front of this integral, I can write 1 over 2. Why? Because 1 over 2 times d2x, that's equal to dx, right? So now secant square root of 2x. How do we integrate this? So to do this one, first, secant, it is cosine, right? Cosine, it is sine. Okay, 1 over cosine squared plus 1 over tangent. Okay. Secant square root of 2x. Okay. Let me just write here. We know that's what is tangent of x squared, I'm a prime, that's equal to secant square root of x, right? Because if you differentiate this, that's secant square root of x. So now we can just write it as then 1 over 2. And what function derivative is secant square root of 2x? That is tangent. So here we have tangent of 2x plus c. Okay. So again, in the first initial condition, y of 0 is equal to -1. Y of 0, which is equal to 1 over 2 times 0 plus c, that's equal to -1. So that's equal to -1. Now from here, C is equal to -1. So dot, 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 our function then y of x will be equal to 1/2 times tangent of 2x minus 1. So that is from the previous one, what was secant square root of, oh, secant square root of x plus 4. I forget something here. So here we have plus 4 dx, 4 d 2x. Let me just write like this. Here we have secant square root of 2x d 2x plus integral 4 dx. So that 1/2 tangent to x plus, and here we have 4x plus c. So when it is 0, actually is equal to 0, -1, it doesn't change anything. So it's -1. So here we have plus 4x minus 1. Okay. Guys, as I told you, we're going to have a bit short classes, but 6 meetings, okay? That much is enough for today. Tomorrow, we will practice questions from 5.6. And also, if you have any question from this chapter, you can just let me know. Just send me the question number or screenshot and just send me the question. And also, I'll try to solve those questions during the class time, okay? Thank you very much. Have a good day. I'll see you tomorrow at the same time, okay? Thank you. Bye-bye. Goodbye, support.
Bye, sir.
Bye-bye. Thank you.
Goodbye, sir.
Goodbye.